Hello everyone, and welcome to the Quantpedia Explains Trading Strategies video series. Today, we will discuss robustness testing of ETF momentum strategies.
Hello everyone, my name is Radovan Vojtko and I'm CEO and Head of Research at Quantpedia. Today we will discuss robustness testing. We'll try to change variables in some trading strategy. We will try to find out how does the performance change of the trading strategy. Now that's basically the characteristic of robustness testing. So we are trying to find out if the strategy is still working when we change the parameters. What are the strategies that we will backtest, and we will perform the robustness testing. It's a country momentum and asset momentum strategies. To factor in country equity, this is a strategy where you have an investment universe and you select the best performing countries out of that investment universe, and you hope that those best performing countries will outperform some benchmark. And momentum asset allocation strategy in assets, it's once again you have a pool of ETFs, but in this case they are not countries, but they are different asset classes like commodities, bonds, equities, gold, etc., etc. And once again you are trying to pick those ETFs that performed the best in the past based on the momentum measure, and you hope that those ETFs will outperform in the short future. So those are the two basic strategies that we will try to run our robustness testing. For those strategies we created a completely different code. The code is available for download in the article, so you can download the code, you can play with it, you can see how does robustness test look like. So there are different variables. So when you have a momentum strategy, you have a variable rate of change. That's the length of the momentum period. The default value is 12 months, but we tried multiple different periods. Then there is a simple account variable. So that's how many ETFs you select into your portfolio. There is of course possibility to change the trading fees, and there is a long and short universe. What is a long and short universe? The reason for that is because we are measuring the alpha. In the code, we are measuring the outperformance of the momentum strategy against its natural benchmark, which is the equally weighted portfolio of underlying ETFs. What we are altering, so we will systematically alter three key strategy variables. That's the number of selected ETFs, is the liquidity of the ETFs, and the length of the sorting period. And we will try to evaluate the impact on the strategy performance and reliability. Firstly, we perform the robustness testing with the usage of the highly liquid country ETFs. We selected subset of ETFs for the countries which have really high liquidity. We omit the US market. The reason for that is because on the previous articles we have shown that United States are around 50% of the global equity market cap, so it doesn't make sense to include the US market into the momentum strategy. It makes sense to build an independent model that evaluates the US versus the rest of the world, and not just include the US market into the sample. We already did, and we already created the model like that in another of our articles, why the US stocks outperformed emerging market and the AFE region. That's the reason why there is no US in the sample, but we are using another 10, 11 ETFs that are all very liquid. This is our high liquidity investment universe. In that high liquidity investment universe, we try to change variable of number of how many symbols do we select in our portfolio, and we compare the momentum strategy to the benchmark. And here in this chart you can see already what is the alpha, so what is the outperformance of the momentum strategy against the fully weighted investment universe. As we can see, the performance from the beginning is mostly zero or slightly negative, so it means that in the underlying alphas are negative and underlying momentum strategy is not performing very well. So until 2008-2009 the momentum strategies in own countries performed really well, but despite the changes in the number of ETFs that we select, the strategy did not consistently generate alpha after the 2008-2009 period. The effective of the momentum strategy in this high liquid market is not very high. Then we tried to change the sorting period. So instead of using the default 12 months, we tried 1 month, 3 months, 6 months, 9 months, and 18 months as a sorting variable. So we sorted our investment universe not just on 12 months performance, but on a shorter or longer performance, and then we run the strategy and compare the performance of the strategy against the benchmark. Once again in the chart you can see just the alpha. Once again we have the same results, so the strategy had a very positive alpha until 2008-2009, but after that the country momentum lost outperformance against the natural benchmark, so equally weighted investment universe of those high liquid ETFs. The next, we tried to run the robustness test on ETFs with low liquidity. We had a hypothesis hypothesis that when we change the liquidity or when we change the investment universe to countries that have the low liquidity, so to small countries like, I don't know, Austria, Belgium, Netherlands, so the ETFs with the small liquidity, that the strategy will improve. Once again, it didn't happen. We still have negative performance against the benchmark. We can change the number of variables. We have negative performance, and also when we change the sorting period, so we use different sorting period, not just 12 months, we still have the negative performance against the benchmarks of negative alpha. Those findings suggest that lower liquidity doesn't necessarily lead to increased alpha. Then we tried another idea. So let's imagine that we will go long countries from the low liquidity group, and we will short equally weighted investment universe of the countries that are highly liquid. Unfortunately, the results were again not favorable. Why did this? Also, we could change the number of symbols, or we could change the sorting period. The question is why? Probably that's because of the survivorship bias. So in our investment universe that's selected in 2023, we focus on highly liquid country ETFs, but I mean those highly liquid country ETFs that could be very lucky survivors. So they had the high liquidity and high market cap because they performed extremely well. And on the other hand, we had the countries that were in the low liquidity group that could perform not so well as the high liquidity group. So when we were using the momentum and we were picking ETFs from the small, illiquid, unlucky survivors, they had a smaller performance than our benchmark that consists of lucky survivors of the countries that are very, very liquid. That's the result for country momentum. So we can see that for country momentum, we can try a lot of different robustness tests, but still the country momentum strategy performs well on absolute basis. So on an absolute basis, the momentum factor on country ETFs performs positively, but on a relative basis, when we compare this strategy against the benchmark, it has mostly the negative performance. Now, then we tried the asset universe. So instead of countries, we selected ETFs that consist of different assets. And then we try to run the momentum strategy on top of that, and the result was completely different. Here is the list of ETFs that has a high liquidity. So as you can see, all of those ETFs are very, very liquid. And then we try to run the strategy, and we try to find out what is the performance of the momentum strategy compared to its benchmark. And we checked if there are some number of selected instruments for which the strategy outperforms the benchmark. And we can see that once we have the strategy that diversified enough, so we do not select one or two ETFs, in which case we have very volatile strategy, but in case we select more ETFs, so we are more diversified, like 5-6 ETFs, we have a positive alpha against the benchmark. So our strategy has a positive total performance. So this is the total performance of the strategy, but it has not just the positive total return, it has also the positive alpha against the benchmark, against the fully weighted portfolio that consists of these ETFs. So our momentum model is outperforming the benchmark. Then we tried to change the sorting period. So we tried different sorting periods, and once again, all of the sorting periods had the outperformance. The per annum outperformance was from 0.3% until 1.8%. Alpha was significant compared to our momentum using just country ETFs. Then we tried ETFs with a low liquidity. So for each asset from the first group, we try to find out the ETF that has a very, very small liquidity compared to the first ETF from the high liquidity group. And then we run those tests again, and once again on the low liquidity universe we have the outperformance. And when we change the sorting period, we are able to find even the strategies which have the alpha around 2 or 3%. So that's like, significant alpha on ETFs compared to the average equally weighted investment universe of those ETFs. So the momentum outperforms. Then we tried going long the low liquidity asset ETFs and short the high liquidity asset ETFs. The results were mixed, but for some of the specifications of the strategy, we were able to find the positive alpha. The question is why there is a difference. So why there is a outperformance, or we have alpha in a momentum strategy when we are using the asset ETFs, so when we are really globally diversified among multiple assets, but there is no alpha against the equally weighted investment universe when we are using just the country ETFs. One of the reasons is probably the correlation. Country ETFs, they are often very correlated. Of course, each ETF is for individual country, but they can go up or down all together because their performance can be significantly affected by the same macroeconomic shocks. But we do not have the same similarity for asset ETFs, because for asset ETFs they are less correlated, so the landscape is significantly less correlated, and The diverse nature of those ETFs means that when they are influenced by the market drivers, they are influenced significantly differently. So they provide a diversified graph for momentum strategy. The assets react differently to market stimuli, and this allows positive alpha generation for momentum strategy, because the momentum strategies, they can exploit these different responses from different assets. Diversity in the asset universe provides multiple opportunities for a momentum strategy to capture the alpha. So what does it mean is that when you are building the momentum strategy, it's very, very good idea to include as many different assets as you can into the investment universe, because then for the momentum strategy, it's significantly easier to find those long-lasting trends and to outperform just simple benchmark, which is equally weighted portfolio of those assets that you have in the investment universe. The momentum strategy works best when you have the diversified portfolio, and it is not working so well when your portfolio is highly correlated. So that's the main conclusion from our robustness. And you can use also this article as a framework how to do the robustness testing of your own strategies. If you are interested in the robustness testing, you may also check our previous article, which is 4 or 5 years old, but it's still interesting. It's called How to Choose the Best Period for Indicators. Once again, the article will show you how to perform the robustness test and how to draw conclusions from the robustness testing. I hope that you liked today's video. Today's article was written by Jiang Du, who was the internship student in the Quantpedia during the autumn 2023, and the article was written in collaboration with us in Quantpedia, so with our help. I hope that you like the videos that we creating on Quantpedia. If you like them, please give us a like or subscribe to our channel, and I hope that you will join me in the next video. Thank you.
Interested? Then pick another video to learn more, or subscribe to Quantpedia Pro and try how our analytics and reporting significantly save time spent on quantitative research.